On to problem 5, we've got polar graphs here. The graph of the polar curves r equals 4 and r equals 3 plus 2 cosine theta are shown in the figure above. And they tell us that the curves intersect at pi over 3 and at 5 pi over 3. And they say let r be the shaded region that's inside the graph of r equals 4 and also outside the graph of r equals 3 plus 2 cosine theta as shown in the figure above. Write an expression involving an integral for the area of r. And I know that whenever we're dealing with polar area, I know that the area is going to be equal to the integral of 1/2 r squared d theta from theta 1 to theta 2. But because I'm dealing with two shapes, I'm going to have to take the outer area and subtract the inner area. So it's going to be equal to 1/2 my big R is the circle, which is 4, minus my small r, which is going to be the 3 plus 2 cosine theta. And I'm going to integrate that with respect to theta, and they told us the limits were pi over 3 and 5 pi over 3. So I've got a integral that expresses the area. The area of the outside circle, 1/2 r squared, minus the area of the outside of the cardioid, which is 1/2 3 plus 2 cosine squared theta. All right, part B. So on part B, it says find the slope of the line tangent to the graph of r equals 3 plus 2 cosine theta at theta equals pi over 2. So I know that y is equal to r sine theta and x is equal to r cosine theta. And the reason that I bring this up is that slope is supposed to be the change in y over the change in x, but that's really going to be dy d theta over dx d theta because of the chain rule. So I need to take the derivative of r times the sine of theta. So I've got to take the derivative of r, 3 plus 2 cosine theta, times sine theta. And I've got to take that over the derivative of x, which is going to be r times cosine theta. And in order to calculate this, I'm going to have to use the product rule. So for the product rule, I'm going to have my first expression times the derivative of the second plus my second times the derivative of the first. And the derivative of this is going to be negative 2 sine theta over, here I'm going to have the first times the derivative of the second, which in our case is negative sine theta, plus the second, cosine theta, times the derivative of the first, which is going to be negative 2 sine theta. Now, they give us this theta equals pi over 2, so if I'm looking for my formula, this is my formula as a function of theta. So if I want to figure out the slope when theta equals pi over 2, then I want to substitute pi over 2 into this. Well, I know that the cosine of pi over 2 is 0, and the sine of pi over 2 is 1. So everywhere I see cosine of pi over 2, that term's going to go away. And whenever I see sine of pi over 2, that term's going to be 1. So what I've got is I've got 3 plus 0 times 0 plus 1 times, in this case, negative 2 over 3 times 1, negative 1, because of this negative sign here, plus 0 times negative 2. And I certainly can leave it like that. I don't have to say that it's going to be equal to negative 2 over negative 3 or 2/3. But I can use this to justify what's going on. At pi over 2, my tangent line is a positive slope, but it is a shallow positive slope. It's not increasing very fast. It's actually increasing at less than a 1-to-1 rate. So I get that graphical confirmation of my answer. And on to part C. On part C, it says, a particle moves along the portion of the curve r equals 3 plus 2 cosine theta. For theta between 0 and pi over 2, the particle moves in such a way that the distance between the particle and the origin increases at a constant rate of 3 units per second. In other words, the change in r with respect to time is going to be 3 units per second. And they want to find the rate at which the angle theta changes. In other words, we're trying to find d theta dt. Well, if I look at this from a standpoint, I know r is some function of theta, and I want to know the rate of change of theta with respect to t. So I could say, using the chain rule, that dr dt has got to be equal to dr d theta times d theta dt, and this is the quantity that I'm trying to find. I know that this is 3. And I can find the derivative of this because the derivative of a constant is 0, and the derivative of this is going to be negative sine. So I've got negative 2 sine theta times d theta dt. And I'm interested with what's happening at theta equals pi over 3. So I could say that d theta dt is going to be equal to 3 over negative 2 times the sine of pi over 3. And of course, this is a perfectly acceptable answer, except I do need to indicate units of measure, and I'm talking about how an angle changes. Remember that angles are measured in radians, and my time unit, they told us, was seconds. So this is going to be that many radians per second. So that's problem